Hello everyone, I welcome you all and thank each one of you for being here with me along this video. Today we'll be taking up a few questions from exercise 4.1 of chapter Quadratic Equations in the NCERT book. But before we begin, we must be well aware of what a quadratic equation is. I have taken up the basics of quadratic equations in another video, link to which I am sharing in the description area. You all are most welcome to go through it once for a better understanding. But to continue here, I would like to mention that a quadratic polynomial, that is ax square plus bx plus c, when equated to 0 is referred to as the general form of the quadratic equation. So, ax square plus bx plus c equal to 0 is the general form of the quadratic equation where a is not equal to 0. Now, exercise 4.1 has two types of questions. Here we'll cover the first type. What is type 1? Type 1 is to check if the given equation is a quadratic equation. So before we come on to the questions, let me very quickly sum up the steps that we'll follow while solving these questions. So, step 1. What is step 1? Step 1 is to reduce the given equation. Now, step 2. Step 2 will be to compare this equation with the general form. What is the general form? We already know that ax square plus bx plus c equal to 0 is the general form of a quadratic equation. Now, last step or step 3 while solving these questions will be to decide whether the reduced equation is representing the general form of the quadratic equation or not. Now, there'll be a few terms that I'll be using while I'm explaining the answers here. So just so that you are clear with what these terms are, I would like to put up a very small question to you all. Do you all know what an equation is? Any equation will always have an equal to sign, and an equal to sign has two sides. It has the left hand side and it has the right hand side. All the terms that are coming on to the left hand side are referred to as LHS of the equation, and all the terms that are coming on to the right hand side are referred to as being on the RHS. So these LHS and RHS, these terms will be used while I explain the questions. So just so that you are clear with what I'm saying, I've mentioned this. Now let us continue further and we begin solving the questions. So first part of question 1 in exercise 4.1. X plus 1 whole square is equal to 2 bracket x minus 3. Here we can see that on the LHS, identity a plus b whole square can be applied. What is a plus b whole square? A plus b whole square is equal to a square plus b square plus 2ab. So we'll do that on the LHS, and on the RHS we'll simply open the brackets. So we get x square plus 1 plus 2x is equal to 2x minus 6. Further, we'll take all the terms present on the RHS to the LHS, and we get x square plus 1 plus 2x minus 2x plus 6 equal to 0. We see that plus 2x and minus 2x get cancelled out, and plus 1 and plus 6 will give you 7. So now the equation will be x square plus 7 equal to 0, or x square plus 0x plus 7 equal to 0. Why have we inserted 0x here? We are inserting 0x because it is not changing the initial equation, and at the same time we are having a better understanding and better clarity of what the values of a, b and c are here. So we can say that what is the coefficient of x square in this equation? It is 1. So value of a is 1. What is the coefficient of x here? It's 0 here. So the value of b is 0. What is the coefficient of x to the power 0 here? 7. So the value of c is 7. So just to have a better understanding of what the values of a, b and c are, we are simply inserting 0x here. Now we'll compare it with the standard form. Next step is to compare it with the standard form, and we find that yes, it can be represented in the general form of the quadratic equation. So yes, it is a quadratic equation. Now coming on to the second question, which is x square minus 2x is equal to minus 2 bracket x plus 3. We begin solving this and we see that RHS, on the RHS we can open the bracket. So we'll do that. So what do we get? We get x square minus 2x is equal to minus 2x minus 6. Next is to take all the terms present in the RHS to the left hand side. So we get x square minus 2x plus 2x plus 6 equal to 0. Next we see that minus 2x and plus 2x, they get cancelled out. So we are left with x square plus 6 equal to 0 as the equation. Next we are simply inserting 0x to have a better understanding of the values of a, b and c, and we compare it with the general form or the standard form of the quadratic equation, and we find that yes, it is a quadratic equation because it can be represented in the general form. Next we come on to the third question. Third question is in brackets x minus 2 another bracket x plus 1 is equal to in brackets x minus 1 another bracket x plus 3. We simply multiply the two brackets and we find that we are left with x square plus x minus 2x minus 2 equal to x square plus 3x minus x minus 3. Further we see that plus x and minus 2x on the left hand side can be reduced and can be written as minus x, and plus 3x minus x on the RHS can be reduced and written as plus 2x. So we have x square minus x minus 2 is equal to x square plus 2x minus 3. Further we take all the terms present on the RHS to the LHS and we are left with x square minus x square minus x minus 2x minus 2 plus 3 equal to 0. Further we see that x square and minus x square, they cancel out. Minus x and minus 2x can be written as minus 3x, and minus 2 plus 3 becomes plus 1. So the equation now we have is minus 3x plus 1 equal to 0. Now we compare this equation with the standard form of the quadratic equation and we find that this cannot be represented in this form as this doesn't have the x square term. So we say that no, this is not a quadratic equation. Now fourth question, fourth part of the first question actually. So this is in brackets x minus 3 another bracket 2x plus 1 is equal to x bracket x plus 5. We simply open the brackets on both the sides and we see that we get 2x square plus x minus 6x minus 3 is equal to x square plus 5x. Now plus x and minus 6x on the LHS can be written as minus 5x. So we'll do that. So we get 2x square minus 5x minus 3 is equal to x square plus 5x. Now next step is to bring the terms present on the RHS to the LHS and we get 2x square minus x square minus 5x minus 3 minus 5x is equal to 0. We see that 2x square and minus x can be reduced and written as x square, and minus 5x minus 5x will become minus 10x. So now the equation will be x square minus 10x minus 3 is equal to 0. We compare this equation with the standard form or the general form and we find that yes, it can be represented in the general form, so it is a quadratic equation. Now coming on to the fifth part of the first question, which is 2 in brackets x minus 1 bracket x minus 3 is equal to in brackets x minus 1 another bracket x plus 5. We simply open the brackets here and we get 2 in brackets x square minus 3x minus x plus 3 is equal to x square plus 5x minus x minus 5. We see on the LHS that minus 3x minus x can be reduced and written as minus 4x, while plus 5x minus x on the RHS can be reduced and written as plus 4x. So we'll do that, and the equation that we'll get will be 2 in brackets x square minus 4x plus 3 brackets close is equal to x square plus 4x minus 5. Now in the next step we'll multiply 2 and we'll get 2x square minus 8x plus 6 is equal to x square plus 4x minus 5. Now further we'll bring all the terms present on the RHS to the LHS, and we'll be having 2x square minus x square minus 8x minus 4x plus 6 plus 5 equal to 0. We can see that 2x square and minus x square can be written as x square, while minus 8x minus 4x, this can be written as minus 12x, and 6 plus 5 can be written as 11. So the equation that we are left with is x square minus 12x plus 11 equal to 0. We compare it with the standard form and find that it can be represented in the standard form, and so it is a quadratic equation. Now coming on to the sixth part of the first question, we have x square plus 3x plus 1 is equal to x minus 2 whole square. Now we can see that on the RHS, a minus b whole square identity can be applied. It states that a minus b whole square is equal to a square plus b square minus 2ab. So we'll apply that, and we find that the equation is x square plus 3x plus 1 is equal to x square plus 4 minus 4x. Further, we bring all the terms present on the RHS to the LHS, and we get x square minus x square plus 3x plus 4x plus 1 minus 4. You further see that x square minus x square, they cancel out. 3x plus 4x can be written as 7x, and plus 1 minus 4 can be written as minus 3. So now the equation is 7x minus 3 is equal to 0. We compare this equation with the standard form or the general form and find that this cannot be represented in the form ax square plus bx plus c equal to 0. So it is not a quadratic equation. So next we come on to the seventh part of the first question, which is x plus 2 whole cube is equal to 2x bracket x square minus 1. Here on the LHS we can apply the identity a plus b whole cube, that is a plus b whole cube is equal to a cube plus b cube plus 3ab bracket a plus b. So we'll apply this on the LHS, and on the right hand side we simply open the brackets. We have x cube plus 8. Why 8? Because 2 cube is equal to 8. So x cube plus 8 plus 3x into 2 bracket x plus 2 is equal to 2x cube minus 2x. Now in the next line we have x cube plus 8 plus 6x bracket x plus 2 equal to 2x cube minus 2x. Further, we open the bracket that is present on the LHS, and we have x cube plus 8 plus 6x square plus 12x is equal to 2x cube minus 2x. Now next step is to bring all the terms present on the RHS to the LHS. So we have x cube minus 2x cube plus 8 plus 6x square plus 12x plus 2x is equal to 0. Further, we see that x cube and minus 2x cube can be reduced and written as minus x cube, while 12x plus 2x can be written as 14x. So the equation that we are left with is minus x cube plus 8 plus 6x square plus 14x equal to 0. Or we can simply rearrange the terms and we get minus x cube plus 6x square plus 14x plus 8 is equal to 0. Now in this equation we'll compare the equation with the standard form, and we find that this form or this equation is not a quadratic equation as it cannot be represented in the general form. Alright, so the 8th part of the first question, that is x cube minus 4x square minus x plus 1 is equal to x minus 2 whole cube. X minus 2 whole cube on the RHS, here we can apply identity a minus b whole cube, so we'll do that. What is a minus b whole cube identity? A minus b whole cube is equal to a cube minus b cube minus 3ab bracket a minus b. So this identity will be applied on the right hand side of this equation. We have x cube minus 4x square minus x plus 1 is equal to x cube minus 2 cube minus 3 into x into 2 bracket x minus 2. We further simply open the brackets and we find that we get x cube minus 4x square minus x plus 1 is equal to x cube minus 8 minus 6x square plus 12x. Now the next step is to bring all the terms present on the RHS to the LHS, and we have x cube minus 4x square minus x plus 1 minus x cube plus 8 plus 6x square minus 12x is equal to 0. Now here we see that plus x cube and minus x cube, they get cancelled out. Minus 4x square plus 6x square can be written as plus 2x square. Minus x minus 12x can be written as minus 13x. Plus 1 plus 8 can be written as 9. So now the equation that we have is 2x square minus 13x plus 9 is equal to 0. We compare this equation with the standard form and we find that this equation can be represented in the standard form, and hence it is a quadratic equation. So that is all for now, and thank you very much and all the very best.